Welcome to this session of our class. Today we are going to look at the concept of a cone. Okay, all that cone is about. Okay, and first of all, when you talk about what a cone is a three-dimensional figure which has a circular base and a common vertex. So a cone is like this. Okay, and a typical example of a cone is a funnel. And when you go to the corn mill, what they put your cereals in and then grind them. That is also an example of a cone. Okay, so when you look at how a cone is, so this is the common vertex, and this is what? This is the circular base. So when we are going to look at the curved surface area of a cone, and we also look at the volume of a cone. And before we consider the curved surface area and then the volume of a cone, what we should know is what is made of a cone, the net of a cone. Okay, when you look at how a cone is actually formed from a sector. Okay, a cone is actually formed from a sector. So when you fold a sector, and then this particular, the radius, okay, of the sector, when they come together, they come to form a cone. Let me show you a typical example. You see, let's say this is our sector, okay. A sector is a portion of the area of the circle formed by two radii. So this is, I have taught that in one of the lessons. So this is, let's say this is our sector, this is our radius, this is our radius, and then this is the arc, all right. So when we fold this particular sector in such a way that the radius, okay, coincide, you will see that a cone is being what? A cone is being formed. All right, you can see that we have gotten a cone being formed. I know this may not be perfect, but we've gotten it. Okay, like this. A cone is being formed. Okay. So as we fold the sector, we get a cone being formed. You see that it has a common vertex here, and then it has what? A circular base. Okay, so as the sector is being folded, we get what we call a cone. I believe that you understand the illustration. Okay, so this is what a sector is, and we fold it and we get what? A cone. All right. Okay, so if you have gotten it from there, let's now come and then we get our curved surface area and the volume of the cone. So what we should understand from here is that, okay, let's say this is our sector. This is the center, and then this is the. Let's use L. Okay, let's use L for the radius of the sector, so that when we come to the radius of the cone, we use R. All right. The cone to the circular base will also have what? We'll have a radius here. Okay, so now let's consider, first of all, we are going to look at the relationship between the cone and then the cone and then the sector. All right, the relationship between the cone and the sector. First of all, let's see the cone, the sector. If you look at the sector here, this is the arc of the sector. Have you seen that? This is the arc of the sector, and the arc of the sector here, all right, is equal to the circumference of the base of the what? Of the cone. The arc of the sector here, all right, is equal to the circumference of the base of the cone. Let's come back to our illustration again. You see, this is the arc of the sector. When I fold it, you see that the arc, okay, will now become the circumference, will be equal to the circumference of what? The circumference of the cone. Okay, so we are going to use this illustration and come by some of our formula, the curved surface area. Okay, so let's see. So our sector, let's say that the angle here at the center of the sector is the angle theta. So if that happens, then we know that the length of the arc, okay, the length of the arc, we say that the length of this arc of the sector is equal to the circumference of the base of what? of the cone. All right, so our cone is here, and then this is our what? Our sector. Okay, our sector. So the length of the arc AB, okay, arc AB, we have learned that the length of the arc is what? Theta over 360 times 2 pi r. Here we are using L as our radius, so times 2 pi L. This is the length of the arc, and we are saying that the length of the arc is equal to what? Is equal to the circumference of the base of the cone. Okay, we know that the base of the cone is a circle. The cone has a circular base, so it's equal to the circumference of the circular base of the cone. And what is the circumference of the circular base of the cone? Circumference of a circle is what? Is 2 pi r. So since this particular r is for the radius of the circular base, then the circumference is 2 pi r. Okay, so let's see if we can have common, factors here that we can actually get, so that we make, so here I believe we can find the radius from here. All right, the radius from here. We have 2 pi here, and then we also have another 2 pi here. So what can we do? We can divide here by 2 pi and divide here also what? By 2 pi. So that 2 pi what? Will go. So we can divide through here by 2 pi. Okay, the whole of this, the length of the arc here by 2 pi, and also divide here by what? By 2 pi. Because we have 2 pi here, 2 pi here. So 2 pi here will take off this 2 pi, and 2 pi here will take off this 2 pi. Alright, then what do we have? Our r here will be equal to theta on 360 times the L, where the L is what? Is the radius of the sector. The L is the radius of the sector. So this radius here is the radius of what? Of the cone. So we can conclude that the radius, alright, the radius of the cone, okay, is equal to, or the radius of the cone implies that r is equal to theta on 360 times the radius of the sector times the where theta is the angle the sector subtends at the circumference of the circle. All right, so the theta is the angle of the sector at the center of the circle. All right, the angle the sector subtends at the center of the circle. So this is the radius of a cone. Theta on 360 times L, where L is the radius of the sector. A radius of the cone is theta on 360 times L. That is the radius of the cone. Radius of the cone. Okay. So now, since you have gotten the radius of the cone, let's clear. Okay, you have gotten the radius of the cone. Let's now come to the curved surface area. See, if I look at my sector here, okay, the area of this sector, when I fold it to form a cone, becomes the curved surface area of the cone. Become the curved surface area of the cone. So let's see how we will get that. The area of the sector. So area of the sector is equal to the curved surface area of the cone. So let's see the area of the sector. What is the area of the sector? It will be theta on 360 times pi L square, because now we are using L, pi r square, L square. So we are using L for the sector. Okay, and we are saying that it will be the same as the curved surface area of the cone. So the area of the sector is equal to the curved surface area of the cone. So therefore the curved surface area of the cone is theta over 360 times pi L square. But you realize that with the cone, we have to use the radius what of the cone here, okay, so that in short we can get a simple formula for the curved surface area of the cone. So we know that from the radius of the cone is what, theta on 360 times L. Okay, so this can be written as, so that we can substitute this, theta on 360, okay, times pi times L times L. All right, so we can say theta on 360 times pi times L times L. So this is what we have here. So I want us to write in such a way that we can get the radius here and do our substitution. So we have theta on 360 times L, you see this is the radius, times pi L. All right. You see that we have theta on 360 here times 1 of the L. So what will be left? Times pi L we have here. And what is theta on 360 times L? That is the radius. So we have the radius times pi L. Okay, which in short will give us pi R L. Pi R L. So the curved surface area of a cone is equal to pi RL, pi RL, pi RL. So that is the curved surface area of the cone, pi RL, pi RL. So you also put this one that we have the curved surface area to be pi RL, pi RL. And you have gotten that from the area of the sector. You see that we have gotten that from here. Alright, so that is the curved surface area of a cone. Then what is left about the cone again? Okay, so we have gotten the radius of the cone. We have gotten the curved surface area of the cone. Alright, so sometimes you can be asked to calculate for the total surface area of a solid cone. When you talk about a solid cone, the cone that the base area, okay, is close. We have the base, the circular base to be close. And we are asked to calculate the total surface area. When it happens like that, you calculate the curved surface area. Then you add the area of what? Of the circular base. So we can have our total surface area of a solid cone, or we say a closed solid or closed cone. All right, solid or closed cone. It means that the base is close, and we are asked to calculate the total surface area. So that will be the curved surface area, which is pi RL plus the area of the circular base. What is area of a circle? Pi R square. So the area of the circular base here is pi R square. That is the area of a circle. So here we can do factorization. Pi R is here, pi R is here. So we can factorize pi R out, and what will be the L, and here will be left with what? R. So this can become the total surface area of a solid or circular or a closed cone. Pi R into bracket L plus R. That is pi RL plus pi R square. Okay, so we have the total surface area to be pi R into bracket L plus R. That is about the total surface area of the cone. Now, I think what is left is the volume. The volume of the cone. So what will be the volume of the cone? Volume of a cone. The volume of a cone is 1/3 the volume of a cylinder. All right. And when you take one of the things you take note is that when you take, there are our 3-dimensional figures. All right. Each volume is the base area multiplied by the height. Okay. So here the height of the cone. Let's look at the height of the cone to be perpendicular to the radius. So we have the height of the cone as this. All right. The height of the cone will become as this. And what you should take note is that this side here, the slant, we call this the slant height. The slant height. Okay, and the slant height L is equal to the radius of the sector C. Let's come to the sector again. When you fold this, you realize that the radius of the sector here becomes the slant height of the cone. So the radius of the sector, okay, will be equal to the slant height of the cone. Okay, sure. So the radius will be equal to the slant height of the cone. That is from here to here will be equal to the slant height of the cone. All right. So our radius here of the sector is the same as the slant height of the cone, which is the L. So okay, now let's look at the volume. As we talk about the volume of a cone is 1/3 the volume of the cylinder. So what is the volume of a cylinder? The volume of a cylinder is pi r square h. Every three-dimensional figure, each volume is the base area times the height, and the base area is what? Pi r square times the height, and this is the volume of what? A cylinder, and the cone is 1/3 that of what? That of a cylinder. So this is the volume of a cone. All right, so I believe we have been able to get the needed formulas on the cone. All right, and when you want to calculate, sometimes you can be given the radius, given the slant height, calculate the height of the cone. That is, you apply the Pythagoras theorem. So this side becomes on the hypotenuse. All right, so the hypotenuse square, my L square will be equal to what? H square plus R square. That is what we can also say. Because this is a right angle, become a right angle triangle. All right, so this is all about a cone. And